Good morning, Dr. Lau.
Good morning.
Well, thank you so much for taking time to talk to me. I'm really excited to learn what I can from you.
Thank
Um,
you for having me. I appreciate it.
yeah, so I'm reaching out. I'm really interested in learning about Europa and try to understanding like what life can live in different circumstances, and then also learning about astrobiology. You yourself are an astrobiologist, so can you tell me about astrobiology, and then just like a little bit about your background in that?
Absolutely. To start off with, astrobiology is the scientific pursuit to understand the origins and evolution and the radiation of life in the universe. So where life comes from, how life changes over time to in different environments, and then how we can find life in different places throughout the universe. And it's kind of a tricky thing to start with because we only know of life in one place right now, and that's our planet. But those of us who are astrobiologists are concerned with how life functions here on Earth, and if we can use that to try to figure out if there is life out there somewhere else, and if so, what we can look for to better understand that life. And so for me, this has been a lifelong passion. Really, when I was a kid, I loved watching Star Trek and Star Wars and other science fictions. I was a huge nerd for this idea of, are they aliens out there? And if so, do they look like us? Do they look different? How would they speak languages? Would they have spaceships? And then, I started reading things by people like Carl Sagan and scientists who were concerned with this question, and started learning that there really is a science to it as well, and trying to understand what life might be like out there. So when I first started college, I really didn't know what I wanted to be when I grow up, and maybe in some ways I still don't know what I want to be when I grow up. But at least then, I was a little aimless at first. I just knew I wanted to study science. And so I started off taking courses in biology and chemistry and physics, and kind of fell in love with biology first off. And that led me into pursuing a degree in biology, and then also a secondary degree in chemistry on the side, since I was really interested in biochemistry and the chemistry of life. And so after those first two degrees, still didn't know what I wanted to be when I grew up then. And so I went back to school for a third time for college, this time to study astrophysics. And I did that for a couple of years and got really into planetary science, and then trying to understand, our search for life in places like Mars and Europa and places like that. And that kind of helped me then transition into my graduate program in geology, which I just got my PhD last week. I'm very excited after 6 years in studying geology. And my main focus has been on life on Earth in extreme environments. Primarily, I have a field site up in the Arctic on a place called Ellesmere Island. It's about 600 miles shy of the North Pole. And in this place, there's a bunch of sulfur that comes out of this glacier in these large spring systems. And it's considered an analog or a similar environment for Europa for us to study that world and what goes on there.
Yeah, that's so cool. So basically, if we find aliens, you'll be the first to know, right?
One of the first, yeah. Our community is very good at sharing information, and so whoever are the very first scientists, the first researchers to discover life, when this does happen, and I think it will at some point. It might not, but I think it will. When it does happen, someone will find out first, and then they'll go to all of the community of scientists they know before releasing the information and just say, "Hey, we have this really cool finding. We're pretty sure it's this, but can you please just check with all of your tools of science too before we go and make a big announcement?" So very often in sciences, we'll check ourselves first before we release the information.
That's so
Uh,
cool.
but it won't be held or kept secret by any government agencies or anything. We'll definitely make sure people know
No
as
men
soon as.
in black.
Yeah, exactly. Yeah, we'd be too excited as scientists to hold on to it for too long.
Awesome. So you shared a little bit about what you do. So what are just the different roles that you can do with a background in astrobiology?
Yeah, astrobiology is really cool. Astrobiology is this really diverse science that incorporates so many other disciplines in research and in engineering as well. And so there are people who are astrobiologists who are also studying, for instance, acid mine drainage systems around mine environments here on Earth. There are astrobiologists who are oceanographers, who are studying how waves work on our planet. There are astrobiologists who work on building spacecraft and are interested in designing these instruments that will be using them to look for life in other worlds. And there are so many different people working in the realm of astrobiology. I'm actually going to a conference next week in Arizona for astrobiology. It's held by NASA. And I'm really excited. There's a bunch of different sessions in talking about Mars and Europa and life on Earth and ancient life and the origins of life and evolution through time, talking about possibilities for life on exoplanets and other places. And so there's just so much in astrobiology. And then outside of the research, for people who are interested in astrobiology but maybe don't want to go get a college degree or a PhD in the sciences, there's also a lot of work in communicating the science and like creating videos and doing graphic arts and website design and all kinds of cool stuff that we have a whole group of people who are involved in that side of astrobiology as well.
Yeah, that's so cool. And especially like, you're going to a conference with NASA. I mean, geez, that's like top tier. So if I was interested, in high school becoming an astrobiologist, like what are the, classes I should take? What should I really focus on, just to like feel if it's really right for me?
Yeah, so when I went to college, like I said, I studied biology and chemistry primarily in my first college I went to.
Hmm.
That was a small school back in Pennsylvania, and they didn't have any classes there in astrobiology. And a lot of colleges don't have a class in astrobiology. Some do, like where I'm at right now, the University of Colorado. We have an astrobiology class. University of Washington, Penn State. There are some other schools that have it, but for the most part, a lot of places won't have specific degrees or classes in extraterrestrial life or in astrobiology. And so the better thing to do is just keep a broad mind when it comes to trying to understand science and the implications for everything we learn through science about our own world and life here, and what that can mean then for our search for life elsewhere. And so for the high school student who's really passionate about it, there's a lot of great stuff out there on the internet from websites. NASA has their own astrobiology group, the NASA Astrobiology Institute. They post really awesome articles about all the things that those of us who are funded by them are doing. There's also some fantastic books out there. I mentioned Carl Sagan earlier. I imagine our young viewers have also seen the more recent version of Cosmos with Neil deGrasse Tyson.
Hmm.
Cosmos is a beautiful show, both versions, and both Neil and Carl Sagan have many books out there in astrobiology. There are other great authors as well who have stuff in astrobiology. So there's a lot you can get started with right now in being prepared for it. Even in high school classes, when you're taking, a high school biology class or a chemistry course or just a general science course, there's a lot of you can do there, and just considering what these tools of science can mean for us trying to understand the role of life on Earth in our biosphere, as well as the possibilities for life elsewhere.
That's so cool. So you've already like kind of talked about it, but just really so I understand, and especially with sciences, I feel like sometimes people are like, oh, well, this doesn't matter to me and stuff like that. But why is astrobiology important for us to understand and to study?
Yeah, so for me, I think the biggest draw for me into astrobiology was that the questions we're bringing up here, are we alone? Why are we here? What more is there? Those are questions that have been around since the dawn of humanity, since our civilizations really began, and since humans first started questioning their place in the universe. And we've come up with lots of tools through time, through theology and philosophy and science, and different ways of trying to understand ourselves and our place here in the cosmos a little better. And so for me, astrobiology has this really cool bridge where it brings together those questions from this philosophical aspect of our understanding of ourselves to the science of how we actually now interrogate our planet and our place here. And so astrobiology really has all these fun interweaving channels where you can bring those larger questions together with some more very specific targeted questions about life. And for instance, there are people who are astrobiologists who are also philosophers. For instance, here at the University of Colorado, Carol Cleland is a philosopher, and she's been looking into this question of what is life. Can we define life? Should we try to define life? It's actually really difficult for us to get a really good, straight definition of life. And the problem is, when we start looking for life elsewhere, we might find some things out there that we think are life, but we're actually not sure because they don't fit into our current conception of life here as we know it. And so it's kind of cool to start asking those larger questions from astrobiology through philosophy, and that's really, I think, what got me really intrigued in the first place was that it gave me a chance to be a scientist, but also to kind of wear that philosophy hat as well.
Yeah, kind of just like what is our place in the universe, kind of falling in line with that.
Yeah.
Totally. That's really cool. I never thought about it like that philosophically. That's awesome. So we're here to talk about Europa. Just as a basic question, what is Europa? I'm assuming it's not like, someplace in Europe that I need to go visit or something.
Absolutely, yeah. Europa is one of what we call the Galilean moons of Jupiter. So those are the first four moons discovered by Galileo Galilei in 1609. When he first pointed his telescope towards the heavens, he was the first person to discover moons around another world, and we call those first four moons the Galilean moons after him. And Europa is one of them. It's a fairly large moon, close to the size of our own moon, but Europa is way different than our moon. Europa is what we call an icy world. So the surface has this icy crust around it, but we're now pretty sure from our spacecraft observations that down below that icy crust is a very deep subsurface ocean. And I actually have some pictures I can share to show that. So this image is showing that moon, Europa, as photographed by the Galileo spacecraft that we sent to the Jovian system, to Jupiter and its moons, back in the 1990s, and it was there through the early 2000s. And in this image, you can see the most visually striking thing about Europa, when we look at images of it, are all these lines here crossing the surface of this little moon. Those lines are actually cracks in the ice. We call them linea, which basically comes from Latin for line. And this image here now shows a little bit higher resolution, so a little bit closer up, looking down at those cracks. And you can see here where some of the cracks start to cross over top of each other, all these different striations. People have actually modeled now, some planetary scientists have modeled how the surface of Europa cracks and moves around. Like these cracks are kind of like faults we have in rocks here on Earth, except these faults or cracks are in the ice of Europa itself. And so we think that down below this cracked, icy surface, maybe 10 kilometers or roughly 6 miles down, there's a very, very deep ocean down below there. And so this image then is kind of showing what we think the general upper layers of Europa might look like, where we have an icy shell. This says maybe 1 to 20 kilometers. The current consensus is somewhere in the 10-kilometer range. And then down below is this deep ocean, maybe 100 or 120 kilometers in depth, which has more water in it than all of the oceans and glaciers and rivers and lakes and streams on Earth put together. So that'd be a very deep, very voluminous ocean, so it has a lot of volume to it. You can see in this image as well, this comes from a paper that was written by two scientists who study Europa, that at the surface of Europa, at the very top, it's really, really cold, negative 180 degrees Celsius. So way below the known temperature range for life. But down inside of that ocean, we actually get a lot closer to 0 degrees Celsius, around freezing, and maybe even above that, down near that rocky area down at the bottom there you see in this picture, where there could be things like hydrothermal vents on Europa. So you might know that on Earth we've discovered these things, these hydrothermal vents in the bottom of our ocean. We call them black smokers here on Earth, and so this picture is kind of showing this mineralized structure from the seafloor here on Earth with all this black smoky material coming out. What happens with hydrothermal vents on Earth is that seawater is kind of comes into the rocks, is heated up by the magma down below, and then is pushed back out in high temperature. And when it comes back out, it carries with it a lot of the chemicals that are stripped out of the rocks. And so it carries a lot of chemistry for life. And here on Earth, these black smokers, these hydrothermal vents, are known to produce very extensive ecosystems where microorganisms can thrive on the chemical energy coming out of those black smokers and then create ecosystems of their own that are completely separated from sunlight. And so just like on Europa, where the sun isn't going to penetrate through 10 or so kilometers of ice down to its ocean, so we wouldn't expect things like photosynthesis, like plants as we know them, to occur in an ocean on Europa the same way they don't occur down in the very bottoms of our ocean where it's very dark. This picture, for instance, the only reason you even see this is because it's actually being lit up by the submarine that's sitting here taking the picture. It's shining a light on it so we can see it. Otherwise, it would be nearly pitch black down in the depths here of our ocean. And so without photosynthesis, the organisms then that are creating these ecosystems, these microbes, are doing chemosynthesis. They're taking the chemical energy from this environment and using it for life, for metabolism and for reproduction. And then they create an ecosystem around themselves. And so here you see on this picture on the right these really beautiful tube worms called Riftiopachia. The image on the left shows those tube worms as well as some of the other organisms in these hydrothermal vent environments that we can find. So deep sea organisms like octopus and fish, but also these little albino crabs and shrimp and deep sea clams. There's an ocean dandelion there, which isn't a dandelion like we have here at the surface. It's a different organism altogether. But yeah, these very large, extensive ecosystems form around those black smokers in the bottom of our ocean. So maybe on Europa, there could also be then, down in that deep subsurface ocean, around some hydrothermal vents, the possibility for these chemosynthetic ecosystems to have developed over time.
Wow. That is really cool. So, so there really is no reason to say that there couldn't be life on Europa then, since there is such a similar circumstances here on Earth, right?
Absolutely. However, we don't actually know yet if there are hydrothermal vents down there. A lot of us think it's very possible. And for instance, another icy moon called Enceladus, which is orbiting Saturn, we've seen that Enceladus has plumes of water that shoot out of this moon. And in the past decade or so, we've been flying our Cassini spacecraft at Saturn through these plumes of water coming out of Enceladus to better understand that world. And actually, there was an embargo on this scientifically until today. The moon Enceladus, some recent spacecraft observations from Cassini have shown hydrogen coming out in those water plumes as well, which suggests to many scientists there could be hydrothermal vents down inside of Enceladus. And Enceladus is a much smaller moon than Europa. So if Enceladus has hydrothermal vents, and we can see that through vents of fluid coming out of the ice, then maybe Europa also has hydrothermal vents.
So does the circumstances, is this the only thing that makes Europa unique, or are there other planets that are very similar to Europa, or moons, or, things like that?
I just mentioned, so Enceladus is very similar as well. So Enceladus is also a little icy moon orbiting Saturn, and it also has an icy shell. And for a while, we weren't sure if its ocean was just in one small spot or actually covered the entire subsurface of the moon. We're now pretty sure from Cassini spacecraft observations that that ocean is extensive around the whole moon, and where those fluids are coming out in plumes then out of the southern region of this moon, it gives us a chance to study it. And Europa and Enceladus are two of the better targets now for these subsurface oceans in these icy worlds. But there are other icy worlds we're really interested in as well, like Titan. Titan is also a moon of Saturn, a very large moon, and Titan has an atmosphere, just like we have here on Earth, an atmosphere. Titan has a really, really thick, very dense atmosphere. And the chemistry on the surface of Titan, it has a lot of water ice, but it also has a lot of methane. And so here on Earth, we have a hydrological cycle where water flows. We have lakes, and oceans, and streams. And water can evaporate into our atmosphere, make clouds, and then rain back down as water, as rain and snow, forming this large hydrological cycle. On Titan, there's a methanological cycle where methane is evaporated, goes into cloud layers and hazes, and then rains back down as hydrocarbons. And so it's basically oil raining down from the atmosphere of Titan. And there are some other icy worlds as well, like Triton, and some other moons that are out there that we're really interested in, that we still haven't gotten some spacecraft to really understand better. For instance, our only knowledge of Uranus and Neptune comes from the Voyager spacecraft. We've never sent missions to those worlds to study them specifically and their moons. And so there's still a lot of research out there for us in planetary science and in astrobiology for understanding these icy worlds. But for many of us who are astrobiologists, I think Europa has just become one of our favorites because it has this really, really big ocean down below. Um, and it seems very, very likely that it could be a very good target for us to better understand if life does exist beyond Earth in our solar system.
So you mentioned sending, spacecrafts and things like that. I know that there's talk about sending a probe to Europa. Do you know anything about that? Can you share some?
I absolutely do. The main, we call them a PI, it's principal investigator for that mission, Bob Papalardo, has also done work with my field site as an analog for Europa, and I very recently had a chance to chat with him about the mission. And I should be seeing him next week in Arizona as well, and so it'd be a nice time to learn more about the upcoming mission. This mission has now gone from concept, so basically just trying to envision what it would look like, to actually making it happen now. So we now have Congress and NASA have allowed us now to make this mission happen, and it recently finally got its official name, which is Europa Clipper. That was the name it was going to be at first, and then for a while we weren't really sure what we were going to call it, and then we're like, well, Europa Clipper is a really good name, and so we're going to use that. This mission, it is a mission designed to study Europa specifically. However, it's not going to go into orbit of Europa. Instead, it's going to go and orbit Jupiter and then go around Jupiter, but each time it goes around, it'll go around Europa as well and give us images and data about the surface of Europa. It'll let us understand that subsurface ocean a lot better. We'll finally figure out, have a better knowledge of the depth of that ocean, the thickness of the icy crust above. We'll learn a lot more about whether or not those cracks actually go the whole way through the ice down to the ocean and may allow for some fluids to make their way up to the surface sometimes. And we're also considering whether or not there could be plumes of water on Europa, just like we found on Enceladus. Some observations from the Hubble Space Telescope these past several years have shown that there may be water plumes coming out of Europa every now and then as well. And so our spacecraft, the Europa Clipper, which should launch around the year 2022, it's well suited to study the surface, some of the subsurface, and also possible plumes at Europa.
Wow, I'll definitely have to be looking for that in 2022. That's so far away, but it probably takes years and years and years to even think up something like that.
Absolutely. Some of these spacecraft missions, they don't just take 1 or 2 years, or a short 4-year, like, if someone's in high school or college. Some of these missions take 10 to 20 years just to get them to the launch pad. And so some of the scientists who are involved in these projects, they will spend over a decade of their lives working on this one mission, trying to get it to launch in the first place, and then they have to get to the target they're going after. So for Europa, right now with our current systems technology, it's going to take about 6 years to get to Jupiter and to Europa. However, we have a new rocket that NASA's been working on called the Space Launch System, or SLS, and that one could get us there in 3 years, so half the time. So we could have the spacecraft to Europa by around 2025, the earliest, which is really cool.
Yeah.
But even after that, then the mission's going to last for a while as we make these observations and do many orbits around Jupiter and get these flybys of the surface of Europa. But all of us in the planetary science and astrobiology communities are super excited for this spacecraft.
Yeah, it definitely seems exciting. Well, thank you so much for talking with me. I learned so much from this conversation. I didn't even know that Europa had water, let alone an ocean, and that there are such similar conditions here on Earth as well. Really gets me excited for the possibility of aliens.
Absolutely, yes, it's really cool, and a lot of us are wondering, not so much, if there are aliens out there now, but when we will find extraterrestrial life. As a scientist, I have to admit it's completely possible there is nothing else, and we are the only show in town. And if that's the case, that's also really scientifically intriguing. But I think it's really likely that at some point we will discover that there is other life out there. And so Europa is just a very good target for us right now to better understand that. Unfortunately, that mission we're sending in 2022, it won't go down to the ocean itself yet. That's still many, many years away because 10 kilometers of ice is really deep to drill to.
Yeah.
But I'm really glad that you learned a lot from speaking with me. I had a great time speaking with you as well.
Yeah, thanks. Have a good day then.
Yeah, you as well. Thank you so much.
All right. Bye.
Bye.
Then we'll cut the recording. Okay, let me actually do that.
Yeah, it's weird that screen share didn't work. That's fine. Yeah, audio-wise, I'm sure it won't hurt at all since we just picked back up. And chances are you can just crop out those toolbars then in
Yeah,
pictures to make it a little cleaner.
I've got confidence it'll be totally fine.
Yeah, I've been learning a little bit of video editing myself to try to start